All right, here we go. Day 2 of our Algebra 1 review for Algebra 2. We are starting off with factoring. Now, there are many types of factoring, and we touched on them all in Algebra 1, and they are used all the time in Algebra 2. We will review them briefly on this, but then they will be used and gone over again and again all throughout Algebra 2. Now, one of the first types of factoring is factoring by finding the greatest common factor. And this is an important one because no matter what other method of factoring we're doing, you always check to see if there's a GCF. There's not always one, but there could be. And if there is one, it has to be done first. Now, what is a factor? Good question. What is a factor? If I give you the number 8 and I said, what are its factors? The factors are the numbers that multiply to make 8. So the factors would be 1 times 8 make 8, and also 2 times 4 make 8. These 4 numbers are the factors. So factors are the numbers that multiply to make a product. Woohoo! All these math words you learned when you were little. Part of the GCF can also be variables, because this is algebra, so we're obviously going to be using lots of letters or variables. So I'm asking, what is the greatest common factor of 45xy squared and negative 60y? Okay, greatest common factor, the largest number and variables that can go into both of these. Now, a lot of times in algebra, to find an answer, we use opposite operations to help us find it. If factors are numbers that multiply to make these two numbers or terms, then I could use division maybe to help me find it. So what is the largest number that goes into 45 and negative 60? We start with our coefficients first, just like we do with most things. The largest number, well, I'm like, well, 3 goes into 45 and negative 60, but is that the largest number? Well, if I did 45 divided by 3, I'd get 15. Negative 60 divided by 3 is negative 20, and they still have factors in common, so I didn't find the greatest common factor. You do need the biggest. So the largest number that could go into positive 45 and negative 60 is 15, because I'm thinking, 45 divided by 15 is 3. Negative 60 divided by 15, or negative 60 divided by 15 is 4. Hey, 3 and 4, I can't take any other factors out of those, so I think I found it. And then we move on to our variables. Okay, now look, how many x's do I have in each of these terms? You can only take out a variable if they have it in common. Again, greatest common factor, that's important. And you can only take out the amount that they both have to give. We want to take out the most that they both can give. Now, this is 1x. Negative 60y has no x's to give. They do not have x's in common. Because they do not have it in common, it cannot be part of the greatest common factor. So x is not coming out as a GCF. Okay? And then I look at my y's. So my y's I have, let me erase right here so we can see better. I have y squared. That means I have 2 y's. And I have y. That's just 1 y. Now, because they have y in common, I can take out some amount of y's. How many can I take? Well, if he has 2 and he has 1, well, they have to give the same amount each. They're limited by who has the smaller amount. So 1 limits it. I can only take out 1y. So 15y, this is just asking me for the greatest common factor. That is the greatest common factor, 15y. It's all that they have. It's the greatest amount that they have in common. Now, when we are factoring, not just finding the GCF, but when we're factoring by taking out a greatest common factor, anytime you're asked to factor, we're saying, hey, take a polynomial, like take something, a bunch of terms that have plus signs and minus signs in it, and turn it back into a multiplication problem. Make it look like distributive property, or make it look like a FOIL problem. But factoring means change it back to a multiplication problem. And when we're factoring by just a GCF, it's going to look like a distributive property problem. So this is the best way that I like to show it. Looking at 14a that I've added to our examples here, I want to factor by finding the greatest common factor for 4y squared minus 24y. Okay, I want to divide out the largest coefficient and the most amount of variables that I can. So I start with my coefficients. What's the largest number that goes into 4 and 24? It has to go into both. Now, my starting point for me is I like to see, does this smaller number go into the larger number? That's a good starting point, because if the smaller number does go into the largest number, then you have found the GCF for the coefficient. Now, it won't always go into, the smaller number won't always go into the bigger number, and if it doesn't, then you have to work your way down in what they have in common. But if it does, then it's a great starting point. So does 4 go into 24? Yes, it does, 6 times. So 4, I found the largest number that goes into 4 and 24. And then I look at my variables. All right, so what I have here, I have y in common. Hey, remember I said it has to be in common. So it has y in common. I can take out a y, but how many? The first term has 2 y's. The second term has 1. How many can they both give? They can both give 1 y. So for y, okay, that is the GCF, but I'm not done factoring. I have to divide it out of each of these terms. Okay, so I showed that, if you remember in Algebra 1, we showed that division kind of like by drawing these circles. And I have to divide the first term by the denominator, and then I'm going to divide the second term by the denominator. Everything gets a term being divided by the denominator. So if I start with 4y squared divided by 4y, I start with my coefficients. 4 divided by 4 is 1. And then when we divide with variables, we subtract the exponent. That's quotient rule. That's why we talked about it last time. So 2y's taken by 1y is 1y. Okay, that was this section here. Now we're going to do the negative 24y divided by 4y. So negative 24, see that negative sign, stays with it, divided by 4 is negative 6. Y, subtract that y, means I have 0 y's left. Okay, it's gone. So this divisor is what goes inside the parentheses. I wrap it up, if you remember, and then my GCF, that's what goes on the outside of the parentheses. This is factoring by finding the GCF. Now the awesome thing about this is I can always check my work. If I distribute this 4y back in or multiply it back into the parentheses, I should get the original problem. 4y times 1y is 4y squared. 4y times negative 6 is negative 24y. Now see, that matches the original problem exactly, so I have done it correctly. Woohoo! We're awesome. Okay, moving on to 14b. What is? We're going to factor, we're going to turn this back into a multiplication problem of 18a squared bc squared minus 48ab cubed. Okay, so we're going to start by drawing a line underneath, and I'm looking for the largest number that goes into 18 and 48. Now I would check, does my smaller number, does it go into my larger number? 48 divided by 18. Does that come out evenly? I get a decimal, so that tells me, okay, 18 is not the GCF. It does not go in evenly to 48. So I have to think, what's another number that goes into 18? Okay, the next largest number that goes into 18 is 9. So I would think, does 48 divide by 9? It does not. Okay, the next largest number that goes into 18 is 6. Okay, does 6 go into 18? Yep, divides in 3 times. 48 divided by 6 is 8. So we have our GCF now. The coefficient, the largest number that goes into 18 and 48 is 6. I had to work my way backwards there, just thinking of what goes into this one, and worked my way down until I found a number that went into both of them. I like to go highest to lowest, not lowest to highest. Otherwise, I don't find the greatest common factor. It could just be a small common factor. I don't even know if that's a real thing, but it's going to be. Okay, then I check my variables. I'm going to write down, okay, we have 2 A's by 18 and 1A by 48. They have it in common, so I can write it down as part of the GCF. How many can I pull out from each? 2 A's and 1, limited by the smaller amount. We always take out the smaller of the two choices, so we can take out 1A. And then we're going to check our B's. I have 1B and 1B. They have it in common. They both have 1. That's how many we can pull out. And then our C's, 2 C's and 3 C's. They have it in common. Write it down. If I have 2 and 3, who's smaller? Well, 2 is smaller. That's how many they can both give. Okay, now what do we do after that? We have to divide it out of each term in the numerator. So I start 18 divided by 6. Do you see how this is quotient rule? So awesome. Is 3. And then subtract the variable's exponents. 2 minus 1 is 1. For b, 1 minus 1 is 0. Remember, we don't write down b to the 0. It equals the number 1, which changes nothing. Then 2c's minus 2c's is also 0. So I don't write down c to the 0. I'm leaving it as 3a. And then I move on to my second term, and I'm dividing it by the denominator, that GCF. So negative 48 divided by 6 is negative 8. 1a take away 1a is 0 a's left. I don't write down anything if there's 0 of them. 1b take away 1b, gone. 3c's take away 2c's is 1c. So this divisor, remember we wrap it up in a nice little package of parentheses, and the denominator is the GCF. It goes on the outside. 6abc squared. Factored by GCF. We could multiply that back out and we would get back to the original problem. Okay, if there's 3 terms, we have to find the number, the GCF that goes into all 3 of these terms. So I need to know what's the largest number that goes into 9, 18, and 24. My smaller number here is 9. 9 goes into 18, but 9 does not go into 24. So 9 can't be the GCF. The only other number that goes into 9 besides 1 is 3. So I'm going to check that. 3 goes into 18. 3 does go into 24. So that is the coefficient part of my GCF. Then I'm going to check my variables. I have R. Okay, they all have it in common. It's part of the GCF. Now, how many can I take out? We have 8, 2, and 1. Okay, if I ever say 1, that's the most I can take out. It just limited us. Whoever has the smallest, that's how many we take out. 1R. And then notice I have 2 S's on the last term, 1 S in the middle term, but the first term doesn't have any S's. So I cannot take out an S as part of the GCF because they don't all have it in common. GCF, the greatest common factor. Remember, common. They all have to have it. So 3R is our GCF. And then we're going to divide each of these 3 terms in the numerator by 3R. So 9 divided by 3 is 3. And then subtract our exponents. 8 minus 1 is R to the 7th. And then I move on to the middle term. Checking my signs. I have negative 18 divided by 3 is negative 6. And then 2 R's take away 1 R is 1 R. And then notice I still have this S here in the numerator. I can't forget about him. We can't leave him out. So S take away no S's because there's not any in the bottom, stays 1S. And then we move on to our third term. Negative 24 divided by 3 is negative 8. Okay, R take away R, 0 R's left, so nothing left to put down. And 2 S's take away no S's, stays S squared. Now remember, that's not the answer. Okay, that is what goes in the parentheses. Wrap it up, put the GCF on the outside. If you're not sure, multiply it back out and see if you get back to the original. If you do, you've done it correctly. All right, our next type of factoring is one of my favorite type of factoring. Remember, factoring means to make back to a multiplication. Now, the amount of terms in a problem helps determine what type of factoring you're going to do. The last example showed factoring by a GCF. Most commonly, we know to do that if there's just like 2 terms. It could be 3, 4, or a billion, but that's kind of a big clue a lot of times. Now, in this problem on 15, we have 1, 2, 3 terms. Remember, plus and minus signs break apart terms. When there are 3 terms, if we're putting it back to a multiplication problem, it's going to look like a FOIL problem where we had 2 sets of parentheses and we had 2 terms broken apart by like a sign in the middle. Okay, a FOIL problem, something like this, a binomial times a binomial. Now, if you remember from Algebra 1, okay, 1, 2, 3, I will say this a lot of times, 1, 2, 3 factor tree is the method we're using here. We are looking for 2 very specific values here. The 2 values that we're looking for always have to multiply to the total of the last value, the constant, But again, at the same time, those two factors have to add to the middle value, which is negative 10. All right, so I hope that you kind of remember this from Algebra 1. So I'm looking for two very specific numbers. There's only going to be two numbers that work for this puzzle, I call it. What two numbers multiply to positive 9 yet add to negative 10? Now, if you see this, multiplying to positive 9 but adding to a negative means I'm looking for a negative times a negative. Because a negative times a negative will give us a positive, yet add to a negative still. Okay, now a lot of times we think 3 times 3. Can my answer be negative 3 times negative 3? I know these two numbers multiply to positive 9. Hey, well, good job. It met this part of the criteria, but do negative 3 and negative 3 make negative 10? No, they make negative 6. See, it has to be negative 10 here, so that does not work. Okay, so negative 3 is not what I'm looking for. So what else multiplies to 9? Well, the only other things that multiply to 9 are 9 and 1, and I know they both have to be negative, so negative 9 and negative 1. They multiply to positive 9, and yet they add across to negative 10. So see how I've met both those criteria? So what I do from there is we just make two sets of parentheses, okay, because I'm making it a FOIL problem. Now notice that x squared meant there was two x's. If I break those two x's apart, each set of parentheses is just going to get one x. Because when I FOIL back out, x times x makes x squared. Okay, we can redo and undo this backwards, forwards, and we always should get the same thing. And then I look at those two numbers and I keep the signs I had. That was a negative 9, so I could put minus 9 and minus 1. Or this could have been x minus 1, x minus 9. Okay, I could flip-flop the order here. It doesn't matter. They're the same thing. Now, always with factoring, you can check. Okay, if I have x minus 9 times x minus 1 and I want to see if I factored it correctly, I could FOIL it back out. I could do x times x to get x squared. X times negative 1 is negative 1x. Negative 9 times x is negative 9x, and negative 9 times negative 1 is positive 9. Okay, and then combine the middle two, and I get x squared minus 10x plus 9. That was the same as my original problem, so I have factored that correctly because I got back to the original problem. But what is my answer? My answer in factored form is that it looks like a multiplication problem. And when it comes to factoring, it really just takes practice and you get better and better at it. The better you know your times tables, the easier this is as well. Okay, so looking at 15a, n squared plus 9n plus 20. 1, 2, 3, factor tree. I am looking for two numbers that multiply to that 20 and add to positive 9. Now, if we have positive signs in both places, the two factors we're looking for are positive. Makes it a lot easier. So what multiplies to 20? Well, I know 10 and 2 multiply to 20, but 10 and 2 do not add to 9. So if I'm going to check 5 and 4. 5 times 4 makes 20. Check. 5 plus 4, adding across, does equal 9. So I have found the right two numbers. These are the only two numbers that can make this factor correctly. So we put two sets of parentheses because we want it to be a FOIL problem. Okay, that's again what factoring is. We'll talk about that more in class. My variable here is n squared. We break it apart to give each of these one of those n's. And then we put positive 5 in one set of parentheses, positive 4 in the other. And again, it doesn't matter which set of parentheses came first. It multiplies out the same. That's our commutative property. Okay, 15b. Okay, factoring x squared minus 11x plus 24. Okay, 1, 2, 3 terms. 1, 2, 3, factor tree. We're multiplying to positive 24, but yet those same two factors that multiply to positive 24 have to add to negative 11. If you're multiplying to a positive and adding for a negative, we're looking for two negative numbers. So I'm thinking 24. A lot of you would know it right off the bat. I mean, I do because I've done this a lot. But if you're thinking like 12 and 2, negative 12 and negative 2 make negative 14. If you're thinking like negative 6 and negative 4, those multiply to positive 24, but they do not add to negative 11. They add to negative 10, so that doesn't work either. So then I think, well, 8 times 3 is 24, and 8 and 3 make 11. Okay, I can just make those both negative. Negative 8 and negative 3 multiply to positive 24, and they add to negative 11. So those are the only two numbers that, remember, they have to fit both of these pieces of the puzzle. So then I write down two sets of parentheses, check the variable that we're using, it's x squared. I break it apart so that we only put one x in each, and then put negative 8 in one, negative 3 in the other. This is factored form. Okay, a couple more examples of factoring trinomials. Again, these are called trinomials because we have 1, 2, 3 terms, and that means we use that factor tree. So multiplying on this one to negative 45 and adding to negative 12. Now, when we have negatives in both positions, I need a negative and a positive number, and the larger number is going to be the negative number, so that it subtracts to negative. So what multiplies to negative 45 and adds to negative 12? For me, the first two numbers I think of that multiply to 45 would be 15 and 3. So I'm going to think 15 and 3, and I would subtract 15 minus 3 is 12. But because I want negative 12, I'm just going to make it negative 15 and positive 3, and negative times a positive makes a negative number and adds to negative 12. We've met both criteria. Okay, those are the two factors numbers. So I'm going to show it in factored form by making two sets of parentheses. Each one gets a positive x, and then we put negative 15 in one set, positive 3 in the other. And again, remember, I'm not going to take time on this video, but you can always multiply it back out to check your work. Okay, 16a, we are multiplying here. We have n squared plus 3n minus 18, 1, 2, 3. We make this little factor tree. That's what this little triangle is called, factor tree, if you remember from 6th grade math. We're multiplying to negative 18, but we are adding to the middle term, which is positive 3. So I have a positive and then a negative. So I need a positive and a negative number in my answer to fit this puzzle, but the larger one will be positive this time because it subtracts to a positive in the middle. So what multiplies to negative 18 and adds to positive 3? Okay, does 9 and negative 2 work? They multiply to negative 18, but they subtract to 7, so they do not fit the puzzle both ways. Okay, 6 and 3. Okay, how about 6 and negative 3? 6 times negative 3 makes negative 18. 6 minus 3 makes 3. Okay, notice these two check marks. It works both ways. So these two numbers, yay, they work. So we're going to make two sets of parentheses. I'm using n squared, so I'm going to put n in each of these. And then I'm going to put a positive 6 and a negative 3. I factored it. I made this problem here into a multiplication problem. Okay, one last example. X squared minus 7x minus 30. We're multiplying to the last number, negative 30, and the two numbers we're looking for to factor this correctly have to add to negative 7. Okay, multiplying to 30. I always think of 5 times 6. Okay, does negative 6 and positive 5, they multiply negative 30, but they do not add to negative 7. So those two numbers won't work, even though those were the first two that I thought of. How about 15 and 2? 15 and 2 will subtract to 13 or negative 13. I don't like that. What about 10 times 3? Let's say negative 10 and positive 3. They multiply to negative 30. They add across to negative 7. So these two numbers are the winning two numbers. They're the only ones that fit the puzzle both directions. So we're going to write this as x minus 10, x plus 3. Ta-da! All right, our next type of factoring is called factoring by applying difference of squares. This can only happen when we have two terms that we are factoring, okay, x squared and 36, and there has to be a minus sign between these two values. Okay, so two perfect squares with a minus sign in between. This is always the method that we use to factor. And again, this will be a FOIL problem as well. So we're going to have two sets of parentheses. And if you remember, one set gets a plus sign, one gets a minus sign. It doesn't matter which one. And then we're breaking apart each of these perfect squares. And how do we undo perfect squares? Well, we do a square root. What is the square root of x squared? Well, the square root of x squared is x. So we put the square root of x squared first in each one. And again, first because it was first in the original problem. And then I look at my second term. It's a perfect square. What's the square root of 36? Meaning what number times its own self equal 36? And that would be 6. 6 times 6 is 36. And that answer goes second in each one. So I'm saying that x squared minus 36 factored, the answer is x plus 6 times x minus 6. Now, we'll shortcut, but this is the answer. But watch what happens when I multiply it out. X times x is x squared. X times negative 6 is negative 6x. 6 times x is positive 6x. 6 times negative 6 is negative 36. And those middle two terms, negative 6x and positive 6x, canceled out to 0. And we're left with x squared minus 36. Okay, that was our original problem. So by taking the square root of each, and they look almost the same. The only difference is one has a plus sign, one has a minus sign. That's why I love difference of squares. It should be so easy. If you know your perfect squares, and we're again going to talk about this way more in class, you should be able to factor difference of squares very efficiently. So now looking at 17a, I have 9b squared, which is a perfect square. In order for a variable to be a perfect square, it just needs an even exponent, because the way we take the square root of exponents is by dividing them by 2. And 100 is a perfect square, so two perfect squares, that's part of the criteria, and a minus sign in between. Cannot be a plus sign, we'll talk about that later. So I'm applying difference of squares factoring, which means, hey, make two sets of parentheses. One set gets a plus sign, one gets a minus sign. Remember, that's how we got those two values to cancel out. And then how do I get the values that go in the parentheses? Well, I'll take the first term and take its square root. The square root of 9 is 3. So put 3 first in each. And then take the square root of the variable if it has one. The square root of b squared is just 1b. 2 divided by 2 is 1. So 3b, was a square root, and it had to go in each set. And then I move to my second term to go second in each set of parentheses. The square root of 100. Okay, what number times itself equals 100? That's 10, not 50. A lot of people say 50. So this factored is 3b plus 10 times 3b minus 10. The only thing that changed was plus and minus sign in each one. 17b, we have 4h squared minus 25g squared. 4h squared is a perfect square. 25g squared is a perfect square. Minus sign is in between. So I'm like, oh, sweet, difference of squares. I'm going to make two sets of parentheses. I'm going to put a plus sign in one set, a minus sign in the other. And then, wham, bam, take the square root of the first term. The square root of 4 is 2. The square root of h squared is h. So 2h goes first in each set. Just here and here. And then next, we take the square root of the last term. What is the square root? Notice I'm leaving that negative sign on the outside. The negative, that minus sign just meant I was able to do difference. Okay, minus sign means difference of squares. The square root of 25 is 5. The square root of g squared is g. So my answer is 2h plus 5g times 2h minus 5g. All right, moving on to a different concept here. How are parallel and perpendicular lines different? Well, all right, so here's, parallel lines. We all know that parallel lines are two lines that are equidistant from each other. They never cross, they never touch. In order to do that, they need to have the same rise over run as each other, which rise over run is another word for slope. Okay, so parallel lines have the same slope. Okay, that's the big thing. Perpendicular lines, see perpendicular lines, if you remember from geometry, they cross at a 90-degree angle. They have to form that 90-degree angle. In order to do that, their slopes have to be opposite reciprocals of each other. So we say perpendicular lines have opposite signs, okay, meaning one is positive, the other is negative, and they are reciprocals, meaning like 3/4 and then opposite sign -4/3. This is an example of two perpendicular slopes, okay? Now, one's positive, one's negative, and then they are flip-flopped from each other. So that's the take home there. Okay, now we're moving on to writing an equation of a line. Now, in the past, you've probably been taught many different ways to write an equation of a line, but if you had me for Algebra 1, I don't want you to worry about point, slope, or any of these other forms. I just want you to remember slope-intercept form, which that formula is y equals mx plus b. That's probably really familiar to you, and that's like the biggest one that you need to remember. If you can remember that, you can solve almost pretty much any equation for a line. Now, you have to remember y is the y value that's going through. M means slope. We have an x value, and b is your y-intercept. So m is slope, and b is our y-intercept, where it crosses, the line crosses the y-axis. So we are being told to find an equation in slope-intercept form, meaning we have y, and we're going to replace m with a number and b with a number. And the equation of our line, it has to go through -1, 2. That's a point. That's an x value and a y value. Whenever we write a coordinate, it's always an x value and a y value. And it has to be parallel to the line y equals 2x minus 3. Now, parallel right here. Why is that important? Well, if we are parallel to y equals 2x minus 3, it has to have the same slope as y equals 2x minus 3. That's what parallel meant. We talked about that on the last slide. So on y equals 2x minus 3, who's the slope? Well, we know that m value is the slope. M value is always a number in front of x, right? Y equals mx plus b. So that means from that equation, m has to equal 2. Now look what we know so far. There's 4 variables in y equals mx plus b, and we know 3 of those 4 values, which means we can do a lot right here. M is 2, x is -1, and y is 2. So watch, we're going to plug those in to y equals mx plus b, and magic's going to happen. Our y value is 2. Put your equal sign. We're filling this in like a formula. M is 2. X is -1. Because 2 variables are touching, I have to put that second value in parentheses. And we know m, x, and y. The only one we don't know is b, so we have to leave that alone. We can solve for b at this point because it's the only unknown. So just think of this as like this giant equation right here. Okay, 2, there's nothing to do to that 2. But 2 times -1 is -2. Plus b. I'm trying to figure out what the value of b is. To be a parallel line, slopes have to be the same, but we need a new y-intercept, a new b value. So how do I solve for b? How do I get this b all the way solved for, or by itself on this side of the equal sign? Well, I have to move this -2 to the other side of the equal sign. So if we move to the opposite side of a line or the equal sign, we use opposite operations. So we add 2 to both sides. So 2 plus 2 is 4. 4 is equal to b. That's our new y-intercept. Now what do we do with that? We go right back to y equals mx plus b. When you make an equation of a line, m and b are the only values or variables that are replaced with numbers. So our new equation will be y equals, all equations of a line should start with y equals m is 2. And the reason why it's staying 2 is because it had to be parallel to that given line, and parallel lines have the same exact slope. So it has to be 2. I'm leaving x as x now, but what I'm putting in is I'm putting 4 in for my new b value. That's the piece I was looking for. So y equals 2x plus 4. It passes through this point, negative 1, 2, but yet it still has the same slope as y equals 2x minus 3. Pretty cool. So this next example will be pretty similar, but this time we want to find a perpendicular line. So I'm going to do this 20a problem. Write an equation passing through the point, negative 3, 5, that's perpendicular to this given line. So remember, anytime you're given a coordinate, we're given an x value and a y value. So x is negative 3, y is 5. And then I want it perpendicular to this line right here. The part that I need from this line is the slope, which is represented by the letter m. So again, go back to y equals mx plus b. Slope is m, so the number in front of x, okay, m is equal to 3/4. But then I have to remember, I want to make a perpendicular line to this one. If I use 3/4, that would give me a parallel line. So perpendicular is, this is a symbol for perpendicular. The perpendicular slope, I have to change the sign from, this was positive, so I'm going to have a negative slope, and then take the reciprocal, 4/3. That's the value for m that I'm going to use to find a perpendicular line. So if I'm using y equals mx plus b as my formula, I know that I'm going to put negative 4/3 in m's position. And then I'm going to fill in my x and my y because those were given up here. So y is 5, so 5 equals negative 4/3, put parentheses and substitute in that x value, which is negative 3 plus b. All right, this is just a friendly equation. We're going to solve for the new b value. We need that new y-intercept. So 5 is equal to negative times a negative will be a positive, and my 3's cancel. You could use your calculator, but I'm left with 4 plus b. Again, how do I get this b by itself? I need to isolate it. That's how we solve for something and we get it by itself. I have to move this positive 4 to the other side by subtracting it. So 5 minus 4 is 1. 1 is the new b value. Now, what do I use? Positive 3/4 or negative 4/3? Because we're making a perpendicular line, we're using negative 4/3. So my new perpendicular line has to start with y equals, and the m value, because we go y equals mx plus b, is negative 4/3. Put that x, and then b value is positive 1. Here's the line that's perpendicular to y equals 3/4 x minus 4, and yet goes through the point negative 3, 5. And then in this next example, we get to skip back to some more basic algebra that I'm sure you all remember very well because you're all brilliant. I have 3x minus 6 equals x minus 2. We are being asked to solve for x. Just like those other problems we do, I say find your equal sign. I would be looking, hey, do I have to expand? Is there any multiplication on either side? There's no multiplication on the left, no multiplication on the right. Check for like terms. 3x minus 6 cannot combine, x minus 2 cannot combine. They are not like terms. So when that's the case, we need to get x's on the left and constants on the right. And you do not have to do that right, but you know that I like to just have a set way of teaching you all to make it uniform. So if I want x's on the left, I need to move this x to the other side. Ooh, that looked ugly. So how do I do that? Again, if I'm going to the opposite side of the line, opposite signs, operation. So I need to subtract x from both sides. 3x minus 1x is 2x. And then here's my equal sign still. I need my constant. This negative 6 needs to go to the opposite side. So we're going to add 6 to both sides. So negative 2 plus 6 is 4. So at this point, I have 2x equals 4. I'm going to divide both sides by 2. That's how I undo that multiplication of 2x. So x is equal to positive 2. All right, let's jump over to 22. Now we're asked to graph a linear equation. Y equals 2x plus 4. So remember, linear, I don't have any exponents attached to x. I'm thinking of comparing this to y equals mx plus b, where still m is still slope and b is my y-intercept. So who's my slope here? My slope is 2, and I could like to think of it as rise over run. So if it's not a fraction, you can put it over 1. Rise over run means it's going to have a slope of going up 2. We always run to the right. Remember, choose the right, run to the right. Same thing for slope. So we're going to go up 2, right 1 from our starting point. Well, the b value is always a starting point, and that is 4 because right, it's in that position. Y-intercept, okay, x goes from left to right, y goes up and down. Y-intercept means it has to cross the y-axis. So we're starting at positive 4 on the y-axis. So we're going to start at 0, 0. That's always our starting point. We're going to go up 1, 2, 3, 4, and we're going to put a nice big dot right there. That's the b value. That's our starting point. And then from there on, we can generate new points by using our slope of up to right 1 from the starting point. So we're going to count 1, 2, right 1, put a dot. 1, 2, put a dot. Now, if I want to make points to the left of that big red 4, I would do the complete opposite. I would move down to left 1, down to left 1. Now, notice it should be in line. It's a linear equation. We're staying in line, and we connect our points with a line with arrows on both ends to show that it keeps continuing on. On 22a, okay, again, if I have y equals negative 1/4 x plus 3, again, y equals mx plus b, my slope is a number in front of x, which is negative 1/4. My b value is what comes after x, which is positive 3. Now, in regards to slope, if we have a negative number, that belongs to the numerator. And if it's rise over run, the opposite of going up is down. But the run is always to the right. Okay, we always run right. Even if it's negative, the negative just means to go down. So your starting point is always the b value. So starting at positive 3, 1, 2, 3, and we're going down 1, right 4 from the starting point. So down 1, 1, 2, 3, 4. Now notice I can't keep going to the right, but if I want to make my line more exact, I could work left and I could go up 1, do the opposite, and left 1, 2, 3, 4. And connect your points. Super fun. Okay, our next example, we are getting into some statistics review. We are given a data set, which is a grouping of numbers, and we are being asked to find the mean, the median, the median, the mode, and the range. Whenever you are doing anything like this, you have to rearrange the order of these numbers from least to greatest, and that can be like the most annoying part of the whole thing. So if I rearrange these 16 numbers from least to greatest, I get 4, 6, 6, 6, 7, 7, 7, 8, 9, 9, 9, 10, 10, 10, 12, and 18. And obviously if you're doing it on your own, it would take a lot more time than that. And there are a total of 16 numbers here. Okay, and that would be a way to like make sure, like count the original and make sure you like have the same amount in your final one. That helps make sure that you don't mess up your data. Now, the first thing that we can find here is our mean. Okay, mean is another word for average. Now, average means that we add up all the numbers and divide by the amount that we have. So if I do 4 plus 6 plus 6 plus 6 all the way down to 18 here, that adds up to 138. And then to find that average, I have to divide by the quantity of numbers I have, which was 16. So I'm doing 138 divided by 16, and I get 8.625. Okay, so that's my average. Okay, next thing that we need to find is the median. Now, median, am I spelling this right? is another word for middle value. Okay, the middle value, that's really just about counting. If I have 16 numbers, half of 16 is 8. So I'm going to divide this so that there's 8 on one side and then the other. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8. So my middle value, like there isn't a middle if you have an even amount. But so that you look on both numbers on either side of that middle line, what number is halfway between 8 and 9? Well, obviously that would be 8.5. But if it doesn't work out to where like you have two neighboring numbers, you would add them up and divide by 2 to get that median. Our mode. Okay, mode means which number or numbers are most frequent in your data set. Okay, now I have, look here, 3 6s. Maybe I should use a different color. 3 6s, 3 7s, 3 9s, and 3 10s. I don't have a number that's used 4 times. If I had a number that was used 4 times, then that would be the mode, but I don't. So because 6, 7, 9, and 10 were each used 3 times, it's okay that I have 4 modes. So my modes are 6, 7, 9, and 10 because they each have 3, and that's more compared to all the others. And then last we have range. Okay, range is your largest value, which is 18 in this case, minusing your smallest value, which is 4. It's like the spread of your data going from like lowest to highest. How many values is that? So 18 minus 4 is 12. So there's our little statistics review. All right, in this next video, we are solving proportions. I love me some proportions. A proportion is when we have a fraction equal to another fraction. And, you know, I like fractions, but we don't want to solve for a variable when it's in a fraction. So we want to make the fraction part disappear. And we do that by cross multiplying. That's when we take a numerator and we diagonally cross that equal sign and multiply it to the denominator. So we're going to take 2 and multiply it to 42. So 2 times 42 is 84. And I'm going to write that down. Now, after you multiply like on one cross, one diagonal, you put your equal sign. And then we multiply on the other diagonal. I'm going to take 7 and multiply it to x. And that goes after the equal sign. 7 times x is 7x. And then sometimes you're left with a pretty basic equation here. We're just doing, how do I get this x by itself? Well, I need to divide both sides by 7. 84 divided by 7 is 12, I believe. I sure hope so. But it is. Okay, that one was pretty simple. Okay, and the case of 25, let's do 26b here. Okay, I have a proportion here. It's a little bit more complex, but I do have a fraction equal to a fraction. We still want to cross multiply. But the thing is, in my first fraction, I have 2 terms in the numerator and 2 terms in the denominator. When I multiply across, 2k minus 3 is going to be multiplied by 5. I think we can all understand that. But 5 has to be multiplied not just to 2k, it also has to be multiplied to negative 3. In a way that we can make sure we don't forget that is whenever there's 2 terms, we need to put them in parentheses. So I would show this as 5 and then parentheses 2k minus 3 to show it gets multiplied to both. And then that was one diagonal grouping, and after that I put my equal sign, and then I multiply the opposite diagonal. 3 goes on the outside, and then we're going to put k plus 9, that grouping inside parentheses. So a little bit more work here, but that just means it's more fun. There's my equal sign. Okay, parentheses always mean that we need to expand to multiply, so I'm going to distribute 5 on the left. 5 times 2k is 10k, 5 times negative 3 is negative 15. I'm going to distribute on the right side of the equal sign, and I'm going to get 3k plus 27. Okay, I'm going to move on down. I have no like terms on the left, no like terms on the right, so I want all my k's on the left. So I'm going to minus 3k to both sides, just solving an equation here so that I have 7k. And then my constants need to be on the right. So negative 15, he needs to move to the other side. We will add him. Okay, cancels. And we get 42. So right now I have 7k equals 42. Okay, to finish that off, we're just going to divide both sides by 7. 42 divided by 7, I think it's 6. Okay, our last example here, we're finding an equation of a line. It's similar to the parallel and perpendicular, but just a little difference in here. It says find the equation in slope-intercept form. Oops, not my pen. Okay, whenever it says slope-intercept form, I automatically should be thinking y equals mx plus b. That describes a line going through 2, 4 with a slope of 0. Always start with what you know in comparison to y equals mx plus b. If they give me a point, that means they've given me an x and a y value. Now, where do they fit in relation to y equals mx plus b? Y is 4 and x is 2. Okay, I'm just filling into this y equals mx plus b. See how much I know. See what's missing. You can find out a lot of what you should do if you know that. It has a slope of 0. Well, slope is the letter m, so we're saying m is 0. Okay, here's my m. I'm going to put 0 right here. So I have so far 4 equals 0 times 2. The only thing they did not give me is the b value. Nowhere in here did it say y-intercept, and that's what b is. So I'm leaving that as my unknown. Awesome. So this is what I know. The only piece I don't know is b. I need to solve for b just like I did on those other problems. So I'm going to have 4 equals 0 times 2 is 0. And I'm left with plus b. Now, if I have plus 0 right here, this one's a little bit different. There's nothing there. Okay, so what is b? There's nothing left to do to solve on this problem, so I don't love it as much. But b is equal to 4. So I want the equation, again, in slope-intercept form, y equals mx plus b. In your final answer, whenever you're creating a line, okay, y stays y, x stays x. I want a number in front of x and a number in the b value if possible. Okay, that's how we like our equations of a line. What is m? Well, it says with a slope of 0, so our slopes have to stay the same here. So the slope is going to stay 0, and our new b value is 4. Now, if we have 0x right here, again, we don't leave 0 in front of a variable, so we would just take that out of the equation and say y equals 4, which does make a horizontal line. Again, we'll talk more about those things later. I like this next example a little bit better, so I'll do this one as well. We want the equation of a line that passes through this given point, -8, -1. Remember, a coordinate is an x value and a y value, and the given slope. So we're saying that m is equal to -3/4. So again, start by filling what you know into y equals mx plus b. Y is -1, or equal sign. Again, the formula tells you how to arrange your values. M is -3/4. That was our slope. It was given. X was given. It's -8. We need a new y-intercept to create a new line. So that's my unknown piece of information right here. Okay, we're solving for b. So the first thing we need to do is multiply -3/4 times -8. So negative times negative will become a positive. 4 goes in 8 2 times, so that becomes 6 plus b. Okay, I'm not done isolating b. I need to get this b by itself, so we need to subtract 6 over, and hopefully as I go throughout these videos, my handwriting will get better. I'm not there yet. -1 minus 6 is -7. We're saying that equals b. Okay, this is the piece that I was looking for. So when I substitute back in, remember when your final answer should start y equals, we need a y. Okay, don't leave that value in there for it. M is going to stay -3/4. X stays x. Again, that's an equation of line. What your final answer, we just need a number for m and b. And our new value, b value is -7. Okay, so good luck on your Google form worksheet that has examples all similar to this. It's like midnight now, so I'm a little loopy. So good luck with everything.